beneath the West Antarctic, a giant sleeps. At 2 million gigatonnes, it is massive. As our oceans warm, the wet sediments beneath this glacier will allow this massive land ice to move, creating a momentum so that nothing will be able to stop it from falling into the sea.
Climate influences the distribution of water across our planet. How much is locked up in the ice sheets, how much is in our lakes, and how much is in our atmosphere. And by changing temperature, you change the amount of water which is in those key systems. You know, under a cooler climate, of course, like during glacial periods, more water is locked up in our ice sheets. And as a consequence of that, you see our oceans levels fall. You know, during the last glacial maximum, about 22,000 years ago, sea level was about 120 to 130 metres on average below present. And as the climate's warmed, more of the water that was locked up in ice sheets, such as over Eurasia and North America, and in the polar regions, melted out and flowed into the oceans, and sea level responded and rose. During the climatic optimum, about 9,000 years ago, sea level was about 1.5 metres, 2 metres above present. So sea level fluctuates in response to that global changes in the hydrological system that are primarily driven by changes in temperature.
If you get melting ice in water, that doesn't make sea level rise. It has to be ice that's on the land, for example, in Antarctica and in Greenland. But the other thing that is very important in sea level rise is what we call thermal expansion. And that's when the water masses around the Earth heat up, and when you heat things up, they expand. When you cool things down, they contract. It's a simple law that all of us learned in primary school. So as the Earth's water temperatures continue to rise, then those waters expand, and so that also adds a component to sea level rise.
Predictions for future changes in sea level vary quite considerably on who you listen to. The IPCC came out with a statement saying that sea level was likely to rise by 2100 within the range of about 0.18 to about 0.6 of a metre, with possibly another 0.2 of a metre of rise associated with water flowing in from melt of temperate alpine glaciers and polar ice sheets. Those predictions are conservative perhaps when you look at some of the other science which has started to emerge in the last couple of years. Researchers have made renewed predictions that suggest that sea level might rise by 2100 by at least a metre, possibly 1.2 metres. And that additional increase is largely a consequence of additional water flowing in from the melt of these large ice sheets, such as in Greenland and the Antarctic, and also some contribution from melting alpine glaciers in temperate mid-latitude environments. There's some big error bars there, and that by and large generally reflects our lack of understanding of how ice sheets respond to changes in temperature. You know, if you warm up temperature and global temperature and you get more melt on ice sheets like the Greenland ice sheet, then how does that respond once the meltwater from the surface starts to penetrate down through the ice and lubricate the ice rock contacts? Does it make the glaciers flow faster? Well, inherently it does, but how fast and what glaciers respond and what speed? We just don't have the ability to include that kind of very complex physics in our models that predict future sea level rise.
Melting ice sheets can also affect Earth's temperature. Ice reflects the sun's heat and energy away from the Earth. As it melts, it is replaced by darker ocean waters. These absorb more heat and energy than ice, increasing the warming effect in polar regions. Satellite telemetry allows our scientists to examine current sea levels with incredible accuracy.
Satellites are in continuous rotation around the Earth around a defined track, and the satellites send signals down to the Earth and they're reflected back up from transmitters, and when the satellites receive the signal there's an exact calculation of how long that signal took to get back to the satellite, and that gives us very, very precise measurements of where sea level is around the globe.
The mean sea level across the planet has risen by almost 17 centimeters in the past century and continues to rise by around 3 millimeters per year. This rate is an order of magnitude higher than the average rate over the last several millennia and is already threatening low-lying island nations with flood events, high spring tides, and storm surges.
In terms of the impact of sea level rise, yes, I am concerned about that from two perspectives. One as a scientist, because inherently the rate and the accelerating rate of sea level rise is a consequence of how we are mismanaging the planet that we fundamentally depend on for our existence, but also as a parent, because you wonder what sort of inheritance you are leaving to future generations.